You'll be surprised of the number of people who actually don't know how to state Newton's second law of motion in words. When a net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the F net and inversely proportional to the mass of the object, right? Now let's do 2.2. 2.2 is saying, let's draw a labeled free body diagram of all the forces acting on the 8 kg block, right? So here's the 8 kg block here. Let's just go ahead and draw that free body diagram. Before we even think of anything, we know we're supposed to have weight, right? Before we even think of anything. And then after that, we can then look at the applied forces and so on. But we're resting on a surface, right? That object is resting on a surface. So we're supposed to have normal force there. And then we have a force applied, which is at some angle of 15 degrees. And then it has a magnitude of 55 newtons, right? And then the 8 kg block is connected to a 3 kg block by means of a string. So obviously we're going to have tension force, right? And then we're also told that there's a coefficient of kinetic friction between the 8 kg block and the surface, which is 0.16. So we also have friction, right, acting on the block. So there we go. We have the normal force, the applied, the weight, the friction, and the tension, right? And we get our full 5 marks. And now 2.3, 2.3.1, a question that most people get wrong. It says that let's calculate the kinetic frictional force that the 8 kg block experiences. So we know fully well that frictional force is equal to the coefficient of friction multiplied by the normal force. We know fully well that the coefficient is equal to 0.16. So now we just need the normal force, and after that we can just multiply the two numbers and get the frictional force. So what will be the normal force when there's a force acting up at an angle, right? The normal force will be equal to the weight, right, minus the y component of the applied force. You'll be surprised. There are people who actually can't calculate weight. But anyway, stories. This formula here, it works when the force is acting on an object like this, sort of pulling it up at an angle, right? When the force is acting like that, that formula won't work. Instead, we're going to have the normal force being equals to the weight plus FAY, right? Yeah, I just wanted to demonstrate that. Yeah, I'm not saying that this formula that I have here will work for every case. It just works for this case. So if we go ahead and find friction, we're going to have friction being equals to the coefficient 0.16, like we've already talked about. And then now the normal force, we need to calculate the weight, right? So we're going to have 8 multiplied by 9.8 and then minus the y component of the applied force. We're on a flat surface. How do we find the y component? We say the force, which is 55, and then sine of the angle, right, which is 15 degrees, right? So the frictional force is going to be, so you just punch that in your calculator, and I'm expecting you to get 10.27 newtons. Pretty much easy and straightforward if you know what you're doing. Last question, 2.3.2. So 2.3.2 says, let's calculate the tension in the string connecting the two blocks. The tension in the string connecting the two blocks. So I just calculated friction for the 8 kg block, right? So I'm also tempted to want to use the 8 kg block in 2.3.2 since I have a lot of information with regards to that block. So for the 8 kg block, I can say that F net is equals to MA, right? F net is equals to MA. And then I say FAX, the BS force pulling the object minus all the other opposing forces, right? That will be the tension and that will be the friction, and that will all be equals to MA, right? But then I can find the X component of the applied force. Obviously I can see 55 cos of 15, right? And then minus the tension, which is what I'm looking for, minus 10.27 is equals to 8 multiplied by the acceleration. So now I can put this in my calculator, right? So that I can only have the tension, right? And then if I do that, I'm getting 42.8559 minus tension being equals to 8a, right? I don't have the tension, I don't have the acceleration. How do I move forward? I call this equation 1 and try find the second equation, right? So now I can move my tension to the 3 kg block. So on the 3 kg block, F net should still be equals to MA. But then now the biggest force pulling the 3 kg block is the tension, right? And then what is opposing? Let's check if we have friction there. Yes, we have friction given to us 5 newtons. So we're gonna have minus FR and then minus FG parallel. This is on an inclined surface, right? So gravity is doing some work there. And then this will be equals to MA. So we're gonna have tension minus 5 for the frictional force and then minus FG parallel. So that will be 3 multiplied by 9.8 sine of 30 degrees, right? The angle is given as 30 degrees being equals to 3a, right? So I'm gonna have tension minus, so now I just have to compute this part here and see what I have, right? So I'm gonna have tension minus 19.7 being equals to 3a, and then this is my equation 2. So we're going to add equation 1 and equation 2. So we're gonna have 42.8559 minus 19.7 and then plus there's really no need for this, but plus minus t plus t, right? They're gonna fall apart being equals to 8a plus 3a, which will be 11a, right? So now we just have 42.8559 minus 19.7, which is giving me 23.1559 being equals to 11a. So now it's just a matter of dividing both sides by 11 and see what we get. If we do that, we get in 2.1051 meters per second squared, right? So now I have the acceleration, I just need the tension. I'm going to use equation 2 because it's smoothly compared to equation 1, if you get what I mean. So if I sub A into equation 1, I'm going to get the tension being equals to 3 multiplied by 2.1051 plus 19.7. So my tension here is 26.02 newtons.